Now we go to a panel discussion, which is predictive maintenance tools to maximize efficiencies and reduce downtime. And as I say, we'd really like to get your questions in for that. And the moderator is Marijin. Apologies, Marijin. I don't know how to pronounce your last name. I think Bezuijen, but you will no doubt correct me. Please do. She is SME and Business Opportunity Manager, Predictive Maintenance at Shell. So with that, Marijin, over to you.
Yeah, thank you. My name is Bezuijen. I'm the Business Opportunity Manager for Artificial Intelligence in Shell's assets in upstream, integrated gas, and downstream manufacturing. I'll be moderating this panel today on predictive maintenance, and specifically looking at some of the challenges into taking predictive maintenance from small-scale pilots to large-scale adoption, supporting remote operation through predictive maintenance, and the applications in the oil and gas industry. I'll be looking to make this session as interactive as possible, so please do use the stage chat function in Hopin for the participants to ask your questions, and do indicate if the question is specific to one of the panel members or a generic question, so I can direct it in the proper way. But before we get started, I'd like to give an opportunity for the panel members to introduce themselves, as well as asking questions that I have to each of the panel members. And I'm going to start with you, John, since people have already seen you, but for those who may have just come in, you want to just quickly repeat the introduction?
Yeah, hi everyone. My name is John Glen, CFO at Spartan Solutions. Stuart Broadley, our conference chair, mentioned this morning that energy transition is the next industrial revolution. Now, I grew up in a Lanarkshire steel town that was once at the centre of the first industrial revolution, and in 1982 I got a ZX81 computer for Christmas and instantly fell in love with software programming. Since graduated from Glasgow University with a degree in computer science before co-founding Spartan Solutions 15 years ago. Now, Spartan's vision is to connect the physical and virtual worlds together to create value, and this gives me a chance to combine my passion for software with my industrial heritage. And we are proud to work with world-leading industrial companies, and we've recently launched our Profis product to help them. So, Profis is a cutting-edge, cloud-based predictive maintenance solution that was developed in collaboration with the OGTC, Strathclyde University, and Repsol Sinopec. And I'm really looking forward to today's discussion on all things predictive maintenance. Thank you.
Subrata, over to you.
Yes, my name is Subrata Bhownik. I'm actually working on the data science and machine learning in McDermott, and we are applying machine learning and data science in subsea digitalization projects. I have some experience in the predictive maintenance for the couple of operators before, and also I have a background in AI. My PhD is also in AI. In McDermott, we are working on mainly for the digitalization for the subsea, and also we are implementing several machine learning initiatives for cost reduction, also for predictive maintenance, digital twin development for, yeah. Thank you.
Thank you. Otavio.
Hello, everyone. My name is Otavio. I'm CEO of Vidya. My background, I'm a metallurgical engineering, and I'm founder of Vidya's company. Vidya's work with digital solutions such as digital twin and AI to asset integrity management for the operation and maintenance phase of industrial assets, mostly for oil and gas assets such as FPSO topsides, subsea equipments or refineries and everything. We are hosted in Brazil. We have several projects here in Brazilian market, and I'm glad to participate on this panel. Thank you for the space. That's it.
Thank you. Harald, last but not least.
Yes. Good morning, good afternoon, whatever. My name is Harald Wesenberg. I'm a software architect and software developer with Equinor. I've been working in Equinor in topics related to software development for the past 25 years. And today I'm working at the research center in Trondheim, where we've been researching technologies such as predictive maintenance for quite a few years. Well, I'm not in the office here, as you can see. I'm in my man cave, but I'm really looking forward to discussing these topics today with the rest of the panel. Thank you.
Really happy to have you all here. As you can see, we have a broad range of experts from predictive maintenance looking at it from different angles. So I'd really welcome the participants to start thinking about any questions that they have for these experts. But I'm going to start with one of my own questions. And John, I'm going to start actually by the question that you suggested, but challenge you to take it beyond just the North Sea. So what do you think in general are the cultural and other barriers to adopting predictive maintenance in mature operations?
Well, I think there are three major barriers to adopting predictive maintenance at the moment, and it was Johan Krebers from Shell yesterday who said, it's all about reducing downtime. So I think there's a clear and compelling reason and desire to introduce the technology. But the three barriers to me are technology itself, culture, and resources. Start with technology. I actually don't think there are any technology barriers of any significance remaining. I think we heard yesterday there's a lot of data in mature basins, and there's some great infrastructure in place. Companies like RigNet, OZSoftPi, there's plenty of live telematics data that we can get access to. And unfortunately, there's lots of downtime events over the last 10, 20 years that we can use to train AI models. So there's no shortage of the raw material and the supporting infrastructure for predictive maintenance. And as I said earlier, the cloud-based latest generation of tools that you can stand up in a couple of weeks that are designed to scale, designed to be easy to use. I think we're getting close to having SaaS-style experiences for predictive maintenance. If you use tools like Slack or Asana, I think we're getting quite close to that level of usability. So I actually think we can move beyond technology now and look at the other two barriers. And the next barrier, to me, is by far the biggest, which is culture. And there was a great session yesterday chaired by BP, where it talked about change management and change management being at least half of the effort to introduce new technology. And oil and gas does have some unique challenges. It's very engineering-led, it's highly regulated, it's risk-averse, and these are all historical facts. But also we have reached a crisis point, not just with the pandemic. I talked about the 14% decrease in reliability. That came from the Oil and Gas Authority and OGTC in a 2018 report. Also said that costs were increasing, O&M costs were increasing by an average of about 2% per annum. At the same time, we now have less people, we've got more work. So we need to support our people a lot better. And I think AI surveillance, real-time surveillance of assets to support experts is really important. Mobile workforce tools to support the offshore teams is really important as well. But we need this culture change to happen quickly. And the third barrier is resources. And again, that's changed because I don't think you need an army. I know you don't need an army of data scientists or engineers or consultants to do this. The latest tools like the pilot and roll out quite quickly. But you still need to assemble a team, an agile team. You need board sponsorship, you need clear success criteria, you need to get to pilot quickly, and then you need to learn from that pilot and quickly scale out the good that you've learned and discard the bad. I think you could with that agile team, an average operator could get a pilot for a platform up and running with 10, 15, maybe 20 days of their effort and involvement. So I think the barriers are reducing, but the cultural challenges, which we did talk about yesterday, to me remain by far the biggest barrier.
Thank you, John. I'm gonna now ask a question for Subrata, and that is, Subrata, do you believe that predictive maintenance can also help in sustainable development, and if so, how?
Yes, thanks, Majan. Definitely, predictive maintenance will help the sustainability issues, because if you look in the current scenario, like there are lots of oil spills are there. If you are able to use digital twin with the predictive maintenance, you can predict this kind of oil leak before, and that will definitely help you to for your sustainability development. And there are several cases out there. It is not the first time we are telling. BP, they have some oil spills in 2016, and as per information we have seen in the news, that Akash Solution is using some predictive maintenance for that. Also, some others, also companies already used a similar type of IoT platform there. So that kind, if you are able to detect this using AI based algorithm, so definitely it will help for sustainability development.
Thank you. Otavia, question for you. How do you believe that digital transformation can change the way operators do remote monitoring of their assets, especially in the current time where remote monitoring is very prominent?
Yeah, sure. So digital transformation means you will employ a pool of technologies such as, I don't know, digital twin, artificial intelligence, machine learning, algorithms, IoT, connectivity, and everything. And I believe each one of them has its a specific opportunity to make things remote, to virtualize, or to bring a way to access or to virtualize your work or your tasks in the operation. For example, for some applications of digital twin, we had experience here. We could virtualize the asset and simulate and predict some results before you act in the physical asset. So with no impact on the physical asset. Other technologies such as laser scanning or photogrammetry could bring data or visual data or 3D data to your I don't know, home office, for example, and you can bring visual inspections and take it off of the field or part of the tasks from the field and make it in a virtual ambient environment. And once digital transformation relies on connectivity, and with deployment of cloud platforms and connections and interoperability of systems, I believe operators can integrate one or several technologies on this way, and this will be resulting in more remote work or tasks, and remotely get results from this investment, for example. So that's how I believe digital transformation can change the operation and turn it more remote.
Thank you, Otavio. Harald, question for you, and this is building on the question that I asked John at the start. What do you believe, in your experience, it takes to make predictive maintenance work on old installations?
Yes, thank you. Equinor, even though the company name is only a few years old, the company itself is almost 50 years old. We become 50 years old in 2022. And therefore, we have a lot of old installations in the North Sea, which were built in totally different eras of sensors and digital infrastructure. So I guess that is one of those things that we need to understand, is how to get better knowledge about behavior of old systems. This comes both down to sensors, and what kind of sensors do we have, how can we deploy them, but it also comes down to knowing how the processing plant is supposed to behave. And for some of our newer installations, we have pretty good process models that can allow us to detect when the process plant is not behaving as expected. And this can then, of course, also be used to identify components that are closing up on failure. But for a better and more diverse range of sensors, we need to be able to deploy them and new kinds of sensors. And that means that we need to have better network connections or other ways of collecting data. And then, of course, all of this has to be done within the cost constraints of operating an old installation, because some of them are nearing end of life, and that means that things might be breaking, but at the same time it might be cost prohibitive to install a wider range of new sensors. So you have to find that balance and get it right.
Thank you, Harald. And I'm going to come back to you in a couple of minutes with a question from the audience. But I first want to ask an audience question to John. And that question is from Mariana Jabo. And the question is, hey, in many cases outside of Europe, cloud adoption isn't so easy because it's not allowed in some countries. And how do you think that barrier can be overcome in those countries?
Yeah, that's a really tough barrier to overcome. I was heartened yesterday when Shell mentioned, I think it was Johan mentioned, that Shell had moved to a full public cloud adoption for their software. And that surprised me a little bit, actually, because if I'd asked that question 2-3 years ago, I think the opposite would probably have been the case. So I think the embracing of the public cloud is a really big driver of this change, as is the industrial Internet of Things. So if you're in a country that can't access the cloud, I think it's a major constraint, and I don't have a simple answer to that. I really don't. I think you're going to struggle, and I think it's about putting pressure on politicians or whatever the drivers are to get open access to the cloud, because it is such a big enabler to scaling up this type of technology, to scaling up artificial intelligence. Without it, you really are going to struggle. So I think there's no easy answer to that. Sorry.
Thank you for that. And even in Shell, even though the majority of our assets, we are able to go public cloud, we do have a few locations where we struggle with that problem as well. Moving on to a specific question for Harald, and this comes from Chris Kaladukas. And that is, what is your point of view on the pros and cons of using in-house data science teams and building applications in-house versus using market solutions for predictive maintenance or other machine learning needs?
Ooh, that's a tough question, both politically and technically. Equinor have for the past 8 years at least had their own in-house development teams, and we see that as the digitalization efforts go ahead, we see that we are starting to both employ more and more in-house development teams, but also that we are getting more and more acknowledged for the work that we do. I think the most important thing to recognize when it comes to software is that software is codification of knowledge. So what you do is that you take the knowledge that is either implicit or explicit in your organization, and then you encode it into your software. And that means that if you're going to make a decision between in-house or outside developers, then you need to make the decision on what kind of knowledge are you trying to encode, and who do you want to maintain it afterwards. If the knowledge is very particular to your company, such as Equinor, then it makes sense to have the software developed and maintained by in-house, under the control of in-house developers. It doesn't necessarily have to be all in-house developers. You can use hired consultants and so on, but it has to be under our control. But if you are trying to encode knowledge about a particular piece of equipment or a particular system that is not particular to your company, then it might make sense to have somebody that knows more about the system do the software development. And of course, the disadvantage or the disadvantage of giving away the in-house development is also that you give away control over how knowledge is captured and distributed across your company. So it's a risk-reward kind of discussion that is more for managers than for developers. Thank you.
Thank you for that. And Subrata, I see a bit of back and forth conversation in the chat on the benefits of going to the cloud versus the edge, and I know from our previous conversations you have some views around this, especially when it comes to remote operation. Would you like to share your views?
Sure. The cloud computing is definitely lots of operators are preferring that, but as you mentioned before, that cloud sometimes, especially the public cloud, some location you will not be allowed to use that, because I have a previous experience of one of the country like Turkmenistan. I'm telling, we have a experience that they are not allowed to use the cloud computing. Then what are the other option is available? That's the edge. So what I understand that that when you are comparing with edge and cloud, edge is better than the cloud. But the reason is edge can gives you through the edge you can do the real-time analytics, and also this is the ultra low latency when you are using the edges. So cloud also sometimes your data are also sometimes costly. So if you think about some subsea system, or maybe I'm talking about like think about a jacket. If you wanted to monitor a jacket, if you install a sensor like more than 100 sensors, and for that if you are transmitting the whole data in a one day, it will not be a small amount. It's a huge amount of data. So the better will be like if you are going through some cloud computing, that means you are processing the data and you decide based on on real time and find out what is going on there, and then based on that if you transmit the data to the cloud, maybe some amount which is necessary to to examine more or something, that will be quite useful. That's called a hybrid. So basically instead of going fully to the cloud or fully to the edge, maybe you can go to the hybrid options also. Edge also have some others option also, because other advantages. Example like a security, because edge now you have enterprise level security, you can use that. Cloud also, yes, but still it is when we compare with edge and cloud, edge is much better in terms of security. And also I can tell you, when you are using edge, that has a huge advantage through the cloud. That means you don't use any, you are not increasing any external cost for the cloud. That means you will predict anything, predict the operation like a pressure temperature, based on pressure temperature or flow rate or something. If you predict something, any anomaly or something, and you can immediately display on the onboard, and based on that your the inspection team can take the measurement, and based on that they can work on.
Thank you for that. Just as a heads up, there's a question in the chat around the learnings from predictive maintenance and how they drive improvement down the supply chain into component design and manufacturing. I'd like you guys to think about that while I first ask a specific question of Otavio, and that is Otavio. What do you think is critical to go beyond a proof of concept or a pilot project when you're talking predictive maintenance, and to scale up to actually improve asset integrity management?
Okay, so In these such projects or digital transformation or digital employment of technology, one of the thing of this project is the integration with other systems, interoperability, and make connections with other sources of data. I don't know, sometimes we need to gather data from the ERP or CMMS or other systems clients already use it. And to deliver that, sometimes in some projects the integration itself is bigger than is a bigger effort than the technology's deployment. So you need to pass through a proof of concept of your technology before you start to make this effort of integration or deliver or develop an integration software, middleware, or something like that. So you do need to have a proof of concept project in the early phases. We have experienced some of them here in our company. We have been doing some subsea equipment proof of concept to gather information from 4 other systems and deliver it in a digital twin of this equipment over the platform, and as well as fabric maintenance, topside maintenance using the platform. But all these projects will need integration with these systems clients already use. So we must validate what clients gonna have as results employing the system before you get this effort of integration and everything. So I believe for that 2 critical points is we must see for 2 critical points. First of them, when we talk about the relationship with a technology company or a small company and a big company such as oil and gas main companies, is the relationship between them is not very balanced. So I believe the big companies must have an upside down strategy to allow the areas, mostly for the operators and operation areas, to give them support to test, to validate, and sometimes to fail in some tests, and to run controlled risks. This will allow them to start testing solutions, digital solutions. And the second point is to have a very well delineated, a very well done scope of the proof of concept or the pilot project, made together between the client or the user and the developer. Or in this well delineated scope must have the concrete deliverables, specific measurable and concrete results you need to get from that project to validate it from in these early phases, and as well as control the risks, know the risks you're gonna, because in this digital projects you will fail in some points, and you will need to overcome these fails, and how you overcome these risks, you're gonna show to the operator or to the user how you're gonna scale up the solution before them. So I believe that this is the 2 points, important points, and the critical points to overcome the proof of concept phase.
Thank you, Otavio. I'm going to come back to the question that was asked in the audience around how the learnings from predictive maintenance drive improvement further down the supply chain in design and manufacturing. Do any of you have a view on this? Otherwise, I can take it, but I want to give you a chance first. John, I see you raising your hand, so go ahead.
Yeah, it's a great question, and it's a use case that we considered for the Profis product. But I think it actually goes back a little bit to the answer Harald gave in terms of internal versus external data science teams and software. Should you build it yourself or should you go to the market and use it? Harald's quite right. It is about coding up of knowledge, and if you've got the time and can afford to build that team and code it yourselves, and you can also manage the risk of the project delivery, then why shouldn't you? But I think the mitigation of that is modern systems have to be open systems. If you encode an expert rule as an operator, you should own that rule. If you put the data in to design a machine learning algorithm, it was your training data, should you own that algorithm? Yeah, you probably should. So I think there's ways and means that contracts and modern tooling and open systems can help mitigate some of the challenges of knowledge ownership and knowledge sharing. And that takes me right onto the use case. If you're surveilling a gas compression system, which has got components from, say, GE, Honeywell, whomever else in it, are you willing to, as an operator, you could in theory slice through that gas compression system and give them a subset of the telematics data, effectively a subset of your digital twin, and share it with your OEM and say, listen, these are the faults that we're finding on this piece of equipment. Here's the actual raw data that's, can you take this kind of slice of this digital twin, and can you come back and tell us how you're going to improve your product for the next generation? And I think there actually is a lot of potential value to be had with that sharing, but I think we then bump into a problem that we touched upon yesterday, which is who owns the data. I mean, is the OEM sharing all of their telematics data with you as an operator, and is you as an operator willing to share your digital twin that you've built up with your OEM, in the spirit of actually getting a better product and reducing downtime and getting better actual engineering. So I can say that the technology is there or almost there to allow operators to share slices of the twins with various OEMs, but I guess it's a question back to the operators. Is that something that culturally the industry is ready to do?
Harald, since you represent the operators here and you're raising your hand, would you like to provide an answer here?
Yeah, I can just continue to build on what John was saying, and not to be bragging or anything, but Equinor is developing its own data lake or data platform, which is called Omnia. But one of the key concepts of Omnia, which is that we will share our data, we will share our telemetry with the equipment manufacturers so that they can run their analytics and give their results or their analysis back to us. That is the key exchange here, is that we give the equipment manufacturers access to our data. They can see their pumps or whatever they have, and they can run whatever analytics they want on top of it. We don't demand to see any data from other companies or proprietary data that they have, but we ask them to then give us back some status or some state or whatever analytics they can give that we can then build on and use further. And we were talking about the digital twins earlier today, and that is one of those good things, is that if you take all of the equipment manufacturers, give them the data, and then have them report state, for example, back, then you can visualize that in your digital twin. If your digital twin is a 3D model, you can then see the state of all the different equipments that you have around. And that, of course, that's the way at least Equinor wants to go. We want to open up our data so that the equipment manufacturers can use them both to help us, but also to improve their own products and services. But it is a hard discussion on who owns the data. Equinor's position is always we own our own data, and the manufacturers own their data. So we just have to find out how to make the best of it. Another nice thing about data, which is kind of different from physical objects, is that data is easy to copy. So there is no rule saying you can't do this or you can't do that, because usually you can do both. You can pipe them into your own data lake, or you can give them to the equipment manufacturer, or you can do both. And that gives you a much better way of having knowledge propagate down the supply chain.
Interesting, thank you. A completely different way that predictive maintenance feeds into manufacturing that we found is that when you do preventative maintenance, you're going to order all the equipment, you're going to order all the parts in advance, right? Because you know. When you do corrective maintenance, you don't have the time to order them anymore. When you do predictive maintenance, you do have some time, but not quite as much. And that's where additive manufacturing techniques, 3D printing, and other similar techniques really come in for us, because in many cases, predictive maintenance gives you enough lead time to actually use 3D printing or other additive manufacturing methods, and therefore reduce your stock levels and save costs that way. Just to share a piece of experience from within Shell. I do see the discussion around POC to production coming up again in the chat. And Subrata, in your experience, what are the challenges to going from that POC and the pilots to actually implementing something in production? I think you have some experience in deep water in that space.
Yes, proof of concept is very important. Because if you look in the market, there are several companies that are working on developing the predictive maintenance software using, within the digital twin platform or separately. But majority cases, if you see that they are still in the proof of concept stage. So I can say that the actual deployment in the realistic scenario, like especially in the subsea or deep water, is very, very less and almost nil. I can tell you, it's almost nil. So they have some implementation in the offshore jackets, offshore jackup units, or in wind industry also they are using some. But if you look into the deep water or subsea, it's very few. Some of the companies, they are still working to develop some of the predictive maintenance software. And the main challenges are, in the deep water, one of the main challenges is data transmission. That is also one of the big challenge. Another thing is also if you measure, if you are installing some sensors or something, it is not only, if you can create some kind of, it is quite easy for testing when you are doing in a lab or something in a software or simulated data environment. But when you are deploying that in a realistic deep water, it's quite challenging. So that is one of the thing. And another thing is, as a EPCI company, we are not a technology developer. So our work is mainly to assist, installation and the procurement and the construction. This type of we are supporting. This predictive maintenance comes under the integrity management and the operation. So it is more and more operation side. So that means if we are developing something, that means operator need to be ready to adopt that type of thing. And also they wanted to, give some option for fulfilling all this type of, check, especially for some kind of collaborative testing or something. So that kind of thing is quite challenging, especially when you are thinking about some large operators. So yeah, these are main challenges we found that. But other than that, the technologies are improving a lot nowadays. Computational powers have been increased. And machine learning, lots of machine learning models came, and they are giving a quite good results when we compare with the realistic. And not only the machine learning, I'm telling for deep water, especially I can tell you some of the things, especially for the risers, for flexible riser. One of the company has developed their riser monitoring system, which is based on that you can go for the predictive maintenance. So they are using basically, instead of machine learning, they're using some other, simple physics-based method, like basically FE-based method, and based on that you can develop. So yeah, so mainly challenges, lots of POCs are there, but still, I can tell maybe 1% to 5%, in 5% they have implemented for the actual scenario.
Thanks for that. And to the audience, we probably have time for one or maybe two more questions. But before we get to that, I'd like to ask a question to Otavio. and that is there's lots of data generated during the sort of design and construction phases of an asset, and how can that contribute to predictive maintenance projects in the later operate phases of that same asset?
Okay, I'm going to answer that in the perspective of relatively new projects. It's our reality here in Brazilian market, which means I don't know, projects from 10 to 15 years old here, and in this perspective, a lot of data is generated in the as you said, in the design, engineering, or construction and commission phase of the assets. For example, we have all the 3D engineering models plus databases or data sets of the design. You have the whole asset attributes of the engineering and design phases, such as materials, operation information, technical characteristics, and everything. You have all the process data from the project, all the installation and commissioning data, such as inspection data and everything. And what we see is that we, in the handover phase from the design, this early phases of the asset, to the operation and maintenance phase, during this handover, most of this data generated cannot be used by the operator, or because of lacks in integration, or lacks in the data structure, or even lacks in the supply of this data to another operator in charge. So, which means that we lose a lot of data in this phase, and the operation and maintenance phase is the longer phase of the assets. I believe it's the most important phase, because it's where the asset is running and making profit. So use this data is pretty important and this is our strategy here, is to collect this data from this early phase of the life cycle of the asset, and use it properly in the operation and maintenance phase. This data is an opportunity. You can, for example, construct and bring together digital twins, predictive models, inventory databases, and put it in service of the operator. So I believe that's it. That's how this data generated in the early phase can help the operators. I believe in more mature assets or more mature projects, which have operated for more time. The whole operation itself phase, or the whole historic data of this operation, have the same characteristics and must be structured, but to be used in the deploy of such a digital solution. So this is how data generated in each phase contribute to the digitalization, for example.
Thank you, Otavio. And probably our last question to Harald. Harald, what do you think are some of the risks associated with implementing predictive maintenance?
Yeah, thank you. That's a complicated answer, but I think just as with software development being encoding of knowledge, I think one of the things to acknowledge when it comes to predictive maintenance is that predictive maintenance is about pushing the envelope. And I think it's important to not push too far, because we have seen lots of examples in the media. We read about the Boeing, or we've been reading about the Boeing 737 MAX problems, which is not a predictive maintenance problem, but it is a problem illustrating the challenges you get when you're trying to use software to push the envelope of what you have been doing before. And I think that this risk of going too far too fast and not knowing the full long tail of anomalies that you're going to get when you start to analyze your equipment is one of those things where you have to build systems of systems that monitor equipment, so that you can, even though one of them should fail or one of them should not show the correct data, the rest of them will still be able to capture what you're doing. So don't rely on single sensors, don't rely on single components, don't rely on all the or a single model or a single analysis. So I was talking a bit earlier about how we were using sensor data in combination with our digital twin to show that even though the sensor itself or the equipment itself is reporting that everything is okay, the digital twin of the process model will show that there is something not correct here, because the pressure drop is too high or the flow is too low or something. So even though the pump or whatever is showing normal, the system itself knows that everything is not all right. And I think building that knowledge is one of those key things that you need to do to be able to do predictive maintenance without unnecessary risk.
Thank you for that, Harald. I'm sure we could keep talking as a panel for another half hour if we wanted to, and there's really good discussion in the chat as well. But I am now going to say thank you to each of the contributors to the panel for a very informed discussion that I think inspires discussion going forward on a number of key hot topics, as well as thank you to all those in the audience who've actively participated, as well as those who've paid attention in the meantime. I really enjoyed this session. I do hope we get the opportunity to speak again at some point in the future. And just want to say thank you to the Oil and Gas Conference for giving us the opportunity to have this discussion. Thanks a lot.
Thank you.
Thank
Thank
you.
you.
Bye,
Bye-bye.
everyone.
Bye-bye.
Thanks.
Brilliant. Brilliantly moderated, Marijin. I should start by saying that super work and a really great discussions coming in through chat feedback as well. So I really enjoyed that. Just a couple of things that I'll just pull out of that. There were many things I could pull out. I really like the direct link between predictive maintenance and additive manufacturing. Kind of makes sense, and most companies have not made that link. So thanks, Marijin. Actually, it was you that mentioned that. It was really super. I also liked this. Only 1 to 5% of businesses have fully modeled their critical predictive scenarios so far. So a huge opportunity still that presents itself to companies there. And I also like the upside down strategy that is required to allow digital solutions to be tested without fear. So once again, excellent discussion.